Okay, now that we know our ABCs of how to measure things, now life gets a little bit more complicated because what is a good measurement? What is versus a bad measurement? How precise can a measurement be? What does accuracy mean? What does it mean to say that your measurement has a range? These are things that we will now jump into because it's not just about getting a reading. You have to get a good, reliable reading in order to be able to do physics. In real life, measurements are not perfect. So, like if you've ever done like a math test, you'll have like a ruler over here and they'll give you these little pretty readings and they'll tell you, okay, here is a pencil. And now, using the numbers you see on the paper, on this drawing, please figure out the length of this pencil. That is very easy to do. But in real life, you get errors. And the reason is because in real life, things are 3D. There's a lot more motion, there's a lot more movement. Things can bend, things can twist. So it's important to be careful when you are taking a measurement and remember that in real life, no measurement is 100% perfect. Literally, even if you try your best, the measurement cannot be 100% perfect. There is something called Heisenberg's uncertainty principle, which comes from quantum mechanics, and you can look that up. It's not in your syllabus. But what that principle shows is that literally, even if you tried your absolute best with the most perfect equipment in the universe, you would not be able to get a 100% perfect measurement. But that's a digression. So, causes of errors. As I mentioned, for example, you can have slight bends which can come in the way. उसके अलावा दिस इज एक्सट्रीमली इंपॉर्टेंट पैरेलैक्स एरर. तो पैरेलैक्स एरर क्या होता है कि आप फर्ज करें यहाँ खड़े हुए हैं and you're trying to measure you're trying to I don't know measure like your sister's height. Here's your sister, and you like have this ruler in the background. So now you are, like this is where obviously you're going to check her height, right? Now your eye is somewhere over here. Now, if you look like this, if you try to see the reading, your eye is not at the same level as the reading. If your eye is like over here, and this is the ruler, and this is the reading you are trying to measure, you are going to measure it incorrectly. आपको सही अंदाजा नहीं होगा. If you are over here, again, आपको सही अंदाजा नहीं होगा. You are not going to get the right reading, and that is because the angle of your eye is not perpendicular to the ruler. It is going to make a difference. You're going to get a reading that is too high or too low. If your line of sight is like this, making a 90-degree angle with the ruler, then you avoid this parallax error and you get the actual reading you are supposed to get. A third cause of error could be, for example, misprints and faded marks on various instruments. There are many sources of error. Other sources of error could be human reaction time. You simply were too slow in starting and stopping the stopwatch, for example. And sometimes equipment can be faulty. So it's really important in physics that when you give a measurement, you usually mention कि अच्छा, this is the extent to which I know this is reliable. And in your lab notes, you mention what could be the potential sources of error due to which this reading may not be entirely 100% correct.